Hello friends, here is my another project in embedded systems, namely temperature controlled system using TM4C123G ARM controller. The main purpose of this project is to monitor current temperature of system and turn on cooler or heater respectively. Also, it will display current temperature value on UART terminal. UART stands for Universal Asynchronous Receiver Transmitter. The COM port in the PC uses the UART. It is often referred as Serial Communication Interface. For the purposes of demonstration, here I am using red LED as a symbol of heater and blue LED as a symbol of cooler. Here I am using 23 degrees centigrade as a temperature set point. That means when temperature will go above 23 degrees centigrade, cooler will turn on. So in this case blue LED turns on and LCD will show message as AC on. When temperature will go below 23 degrees centigrade, heater will turn on. In this case, red LED turns on and LCD will show message as heater on. So now let's see the components which I have here. So you can see here I have 5-volt supply. Then this is TIVA board TM4C123G ARM controller. Then you can see here this blue one, it is 10K port. This is another 10K port. This is LCD. And you can see here this is LM35, which is temperature sensor. Then connecting probes, and to display the output of UART I am using here Terra terminal software. So this is overall system overview. Now let's see block diagram of this system. So this is the block diagram of this temperature controlled system. You can see here it is temperature sensor LM35. This is ARM controller TM4C123G. Output of this ARM controller is connected to LED, LCD, UART, and input to this temperature sensor is given through this 10K port. So let's first see the pin configuration of this temperature sensor. You can see here this LM35 is temperature sensor. It has 3 pins, out of which one is for ground, one is for input voltage, which is in between 4 volt to 20 volt, and one is for output. And the magical thing about this LM35 temperature sensor is that its output is directly proportional to temperature in degree centigrade. That means its output is equal to 0 millivolt plus 10 millivolt per degree centigrade. That means, for example, if its output is 30 millivolt, it is equivalent to 3 degrees Celsius. So you can see here the graph of temperature in degree centigrade versus voltage in millivolt. So it is linear. So here we'll get output in terms of degree centigrade. If you want output in terms of degree Fahrenheit, it's just a matter of mathematical calculation and you will get it. Now to change the value of this temperature at the output end of temperature sensor, I need to change input voltage value of temperature sensor, and to do that, here I am using 10K pot. So by changing the value of this 10K pot, this value of input voltage will get changed, and from that our output temperature will get changed. So let's see how it will work in systems. So in current scenario, you can see that our blue LED is on and LCD shows message as AC on. So let's check what is the value for temperature, and you can see here set point is 23 degrees Celsius and current temperature is 42 degrees centigrade, and in Fahrenheit it is 107 degree Fahrenheit. So now let's turn on potentiometer so that we can see change in temperature. And you can see here red LED is on and LCD is showing message as heater on. And let's see. So here you can see that set temperature is 23 degrees Celsius and current temperature is 0 degrees Celsius. In Fahrenheit it is 32 degree Fahrenheit. So yeah, that's it for this project. Thank you for watching my video.